Good morning. Today. Well, today we're going to continue with our investigation of kinematics, and ultimately we'll discuss this video and what it actually means in terms of this car moving across the screen. So let's commence operations. Today we'll be specifically discussing position, displacement, distance, velocity, and speed. And so, referring to your notes, please open up your package to this specific page. What is position? It's the location of an object relative to a reference, and it ultimately requires a measurement of length or distance and direction. The symbol in physics is d. Notice d has an arrowhead above it. That means it's a vector. The unit is meters. Example 1. A person is standing 5 kilometers east of his home. The E in the bracket stands for east. And so the home here is the reference point. And basically we're saying this person is standing 5 kilometers east of his reference point. Here we have the direction east and west defined. So we would write D equals 5 kilometers east. Please highlight this. If you haven't already done so, please write down that D, or position, is a vector. Now, specifically for this example, if we want to state that someone's position is their initial position, then we would use a subscript 1 in physics. Sometimes in some textbooks you'll also see an I subscript. So for this person standing 5 kilometers east of their home, we would say their initial position is 5 kilometers east. That's how we write it. Now, in this second example, the same person has now moved to a new position, 13 kilometers east of their home. Well, specifically, if we want to show in physics that a person has moved to a new position or a final position, we normally use the subscript D2, 2 standing for final. So please add these subscripts to your notes. D1 equals 5 kilometers east. That's their initial position, east of the reference point, the home. And D2 is 13 kilometers east of the reference point, or their home. Now in physics, when the position of an object changes, we have a specific name for that. If we want to be very specific here, we can say that the person has walked 8 kilometers east from their initial position to the final position. Now the name of this is called displacement. So next we'll talk about displacement and distance and how they can potentially be different. Displacement, the net travel of an object as measured from its starting point to its end point in a straight line. More commonly, displacement is often called the change in its position. The symbol for displacement is delta D. Delta in mathematics or in physics means change. This symbol is often used in mathematics, delta symbol, for rise or run. Now, in our situation, D2 was 13 kilometers, that was the final position, and D1 was 5 kilometers, that was the initial position. And so please fill in this in your notes. For this first example we just did above, delta D, which is D2 minus D1, the change in position, 13 kilometers minus 5 kilometers equals 8 kilometers east. Notice displacement once again has this arrowhead, and that means it's a vector. And so for the above example, the person's displacement is 8 kilometers east, or delta D, and the arrowhead is missing here, so please add it, equals 8 kilometers east. Distance. There are very few situations actually where distance and displacement will be the same. And we'll discuss those situations in a few moments. However, distance is a measure of the total length of path that an object travels along. The symbol for distance is just delta D without the arrowhead. That means that distance is not a vector. That means that distance does not require direction. That's really important. So for the example we just did, the distance traveled by the person was also 8 kilometers. And we would write delta D equals 8 kilometers without any direction. So the only time that distance and displacement will be exactly the same is when the person is traveling, or the object is traveling, in a straight line. That's it. The moment the person deviates from traveling in a straight line in one direction, that's the moment displacement and distance will be different. So keep that in mind. Displacement is the change in an object's position. If an object's position doesn't change, its displacement is 0. Distance is a measure of the total length of the path that an object travels along. They seem similar, and yet there are slight differences. Let's look at an example. Captain Canuck is running a race at a track meet. One lap is a total of 400 meters. If the captain runs 4 laps, find A, the distance traveled, and B, the displacement. So I think this example will clearly show when these two variables will be different. And so here's our track. And let's say that the Captain Canuck here, starts at this point, starts running around the track, runs again, and so on. He's running 4 laps altogether. However, we're going to say that Captain Canuck starts and finishes in the exact same spot. So that's really important to note. So the distance is fairly straightforward, 1,600 meters. If one lap is 400 meters, then 4 laps is 1,600 meters. The displacement, however, is actually 0. Why is that? Well, remember, the definition of displacement is the change in position. Has the person's position changed? No. No, it hasn't at all. He started at this position, Captain Canuck, and he finishes at the exact same position. So if the position doesn't change, then your displacement is 0. For there to be displacement, the object's position must change. So when you get up in the morning and you go to school, then you come back home, your overall displacement for the day is 0. Even though your school may be, say, 5 kilometers away from your home. So you travel in the morning to your school, that's 5 kilometers. You travel back from school to your home, that's another 5 kilometers. You've traveled 10 kilometers altogether. Your displacement is still 0 because your position from where you started off in the morning at your home to where you end up in the afternoon after you come back at home, your position is the same. And if your position hasn't changed, your displacement is 0. I strongly suggest you try these practice problems. These practice problems will reinforce some of the discussion that we just had. And of course, you can find the solution to these practice problems by clicking this link at the website. Here is the website. And because this is a grade 11 course, you would go under grade 11. Because we're studying motion, you would go into the motion unit and you'd find these links here with the full solution. So if you can't get these answers, make sure you click the link found under 11U Physics, click these links, and it will show you step by step how to do these problems. And here's the website up here. All right, continuing on, please turn to this specific page in your notes with sign convention. In physics, when we're talking about displacement or velocity or forces or any vector quantity in general, North is always a positive number and south is a negative number. East is positive and west is negative. Up is positive and down is negative. And finally, right is positive and left is negative. So what does that mean? Well, in general, if we have a position here, say 10 kilometers north, it can be written just as positive 10 kilometers, and it would be understood, or just 10 kilometers, it would be understood that that 10 kilometers is read as north. So you wouldn't have to necessarily write down north here in the question or in your solution, because positive means north. However, if you want to represent 5 kilometers south, this would be written as negative 5 kilometers. And it would be understood that if you have a negative in front of the number, that would mean south. That's what we mean by convention. So 3 kilometers east, because east is automatically, by the convention, positive, it could just be written as 3 kilometers, and it would be understood that it meant east in terms of reference to the question. 10 kilometers south can be written as just negative 10 kilometers. South being understood as being negative. Please try these other examples now. Please pause the video. Go ahead. All right. I've assumed you've tried these questions, and here are the solutions. 5 meters up, positive 5. It's understood. 2 meters down. Well, down is opposite up, so we use a negative to represent that. And west is opposite east, so once again we use a negative to represent that. Let's try this question. A person walks 5 kilometers north and then turns and marches 3 kilometers south. The person stops for a few hours and then walks 2 kilometers north. How far has she traveled? What is her displacement? Please pause the video now and give this a try. All right. I'm assuming you've tried it. So distance is always straightforward. Distance, we just add numbers because for distance, it's not a vector. It's a scalar quantity, meaning direction doesn't matter. It doesn't matter what the direction is when thinking about distance. And so 5 plus 3 plus 2, that's 10 kilometers. That's straightforward. But for displacement, remember, we have to take into account direction. And so the formula looks very similar for displacement. However, notice that when the person has traveled south, we haven't written positive 3, we've written negative 3. So even though the person's distance is 10 kilometers, their displacement is 4 kilometers. That means that they are 4 kilometers north from where they started. Now, does this make sense? Let's see with a diagram. So we start here and we've traveled 5 kilometers north. At this point, what do we do? Well, at this point, we turn back around and we've traveled 3 kilometers south. And then after stopping, we travel 2 kilometers north. And so how far are we from where we started? Well, 5, then we've gone back 3. So right now, at this point, we'd be 2 kilometers from where we started. But now we travel another 2 kilometers, and 2 plus 2 is 4 kilometers. Remember what displacement is. It's how far away are you from where you started? Well, you are 4 kilometers away, specifically 4 kilometers north from where you started. Average speed, the ratio of the distance traveled to the total time. Distance over time, or delta d is the symbol for distance divided by delta t. So this is the formula we just used a few moments ago to determine the speed of the character. The unit normally is meters per second or kilometers per hour. And so 1 meter per second equals what in terms of kilometers per hour? Well, it's 3.6. So the question is, how do we get this conversion? We'll discuss that in just a moment. Now, average velocity is the ratio of displacement to the total time. displacement over time. So it's slightly different. For average velocity, you're going to need a direction. And so I promised you that we would discuss how to convert a meter per second into a kilometer per hour. I want to formally show you this. The final answer is 3.6, but let's see how we get that. So we have to know that 1 kilometer is 1,000 meters. And we also have to know that 1 hour is 3,600 seconds. And so 1 meter per second equals 1 meter per second times a fraction. And we want to convert, now it doesn't matter which order we do this in, but we'll convert meters into kilometers. So we'll use this ratio here that 1 kilometer is 1,000 meters. And notice when we write it like that, the unit of meter cancels out. It terminates. And so what we're left with is 0.001, but now we're no longer left with meters per second because the meters are gone. We're left with kilometers per second. But we don't want kilometers per second, we want kilometers per hour. So once again, we have to fill in a fraction here. And so the question is this. We know that 1 hour is 3,600 seconds. Do we write 1 hour here over 3,600 seconds? Or do we write 3,600 seconds over 1 hour? Well, we want kilometers per hour. Right now we have kilometers per second, so we need hour on the bottom part of the fraction and seconds on the top part of the fraction. So we've just written 3,600 seconds over 1 hour. And now notice when seconds is here and we have seconds there, what will happen? Once again, the units will terminate or cancel. And what are we left with? We're going to be left with kilometers per hour. And as you can see, when we multiply these two numbers, we're left with 3.6 kilometers per hour. So that's how we got a conversion of 1 meter per second into kilometers per hour, 3.6 kilometers per hour. Please make sure you copy all this down. So one of the questions I always ask my students is, what does 40 meters per second mean? Because if you really understand what 40 meters per second mean, or in general what the unit of meters per second mean, then you don't even need a formula. I know I just gave you the formula, speed equals distance over time. I know we just solved for the speed of a character moving in a video game using that formula. But if you just understand what this unit means, then you'll never have a problem manipulating the formula. So what does 40 meters per second mean? Let's say an object was traveling not just at 7 meters per second, but at 40 meters per second. What does that actually mean? Well, it means that every 1 second, in this case, let's say it was a car would be moving 40 meters. So if in 1 second the car moves 40 meters, in 2 seconds the car would move 80 meters. And in 3 seconds, 80 plus 40, 120 meters. And in 4 seconds, 120 plus 40, 160 meters. So if you just understand the unit meter per second or kilometer per hour, you don't even need a formula anymore. Let's look at this example from your notes. A speed skater travels around a 600-meter track in 2 minutes and 12,000 milliseconds. Find the skater's average speed and average velocity. So we're going to use the formula speed equals distance over time. Delta D over delta T. The distance being 600 meters. Time is a bit more complicated. On purpose, I've mixed up the units. I'm a fundamental believer in students really analyzing what a unit means. And so I'm just not going to give you on your test the unit of seconds. You're going to be forced to manipulate these units. So 2 minutes. Let's start off with 2 minutes. Well, 2 minutes is 120 seconds. 1 minute is 60. 2 minutes is 120. 12,000 milliseconds. Well, you have to remember what a milli is. A milli means 1,000. So 12,000 milliseconds divided by 1,000 is 12 seconds. So remember that. And if you don't remember that, please write that down. 1,000 milliseconds is 1 second. 1,000 millimeters is 1 meter. Remember that. So the total time is 132 seconds. And we do our division. And we get 4.54 meters per second. And that's 5 meters per second in significant digits. Why one significant digit? Because the number 600 only has one significant digit, not three, just one. I'd like you to now try to get the average velocity. Please pause the video now. All right, assuming you just tried that. To understand how to get average velocity, we need to look at a track. And one assumption we're going to make is that the person starts and stops in the same spot. So if they start and stop in the same spot as I go around this track, and this track obviously is not to scale, it's much smaller than 600 meters, but if the person starts and stops in the exact same spot, then the average velocity is 0. Why is that? Well, remember, the average velocity is the displacement over time. And in this situation, we're going to say the person starts here and finishes in the same position. So if they start and stop in the same position, that means the displacement is 0. And if the displacement is 0, the average velocity is 0. So the last thing I'd like you to suggest, please try these practice problems from your notes. The solutions are available online, full solutions with answers. And finally, at the very beginning, we opened with this picture. So what does this picture represent? Well, it represents a very tiny remote control car moving across this measuring tape at a constant speed. And you can see that this distance, this white line here, is 25 centimeters. Now, a video was used to record the motion of this car, and then images were extracted. They were extracted every decimal 0.666 seconds, or every 1/15th of a second. They were extracted. And then they were cropped, and this one image was created. And the one thing I want you to notice is that the gap from image to image seems to be very steady. And because it's very steady, when the gap from image to image is steady, we say that the object is moving with constant velocity. And so your task here is based on this image to figure out the velocity of the car and to figure out the time. Have a great day. Bye-bye.